Welcome back to Alex's Computer Lab. Let's continue on with part 3 in which we finish the build of the electronic portion of this controller. Now let's get started.
So, let's get out my headers. I may actually have to go in my stash because I'm not sure if I ordered any single row headers. I think I just ordered dual row. So what you do when you order headers, you get a block of them like this, and these are what are called breakaway headers. They're notched on the edge, so I can take my flush cutters and cut off however many pins I need. So for example, for this I need 6 pins. So what I'll do is I'll push my flush cutters right here next to 6 of them. I'll put them in the gaps. I'll hold them and I'll put my finger on them because these things like to go flying. And again, protect your eyes when doing this, so it's always good to put your hand on it, and I'll clip. So there we go. I've clipped off the pins. You will sometimes damage the plastic attached to some of these. You will end up at some point destroying some pins. It's not a big deal. There's always more. Okay, so now on the other side I need 4 pins for right over here. So I'm going to cut off 4. And again, so far I haven't damaged anything. But again, when you're ordering headers, always order extra. You'll use them for every project. So it never hurts to have extra on hand. So that goes right there. And actually I'm going to rotate it like that. I'll put my clipped lead up and down. So there we go. So there's those. Now I need, looks like I need a set of 2 for there, which I can cut off here. And then I need 2 sets of 3. And those are single row. Oops, 2, not 4. Alex? There we go. And there's an example. You can see I just broke these. That will definitely happen. That's not a big deal. I'll just cut off another one. Okay, trim that. When doing 2, it is easier to use single row headers. If this, yeah, it fails too. Okay, screw it. I'm just going to go out and get my single row headers rather than wasting any more of these. So I'll trim these a little bit to clean them up. There we go. So let's see, put these down, and I think I have some single row headers right behind me. Let's look and see what I have. Okay, and I'll leave me 2 left. Okay, so 3 go here, 3 go here, and then 2 go here. This is where using some tape or something like that can be useful. Some people like to do is they'll stick this into a foam block or something like that. Probably when I try and flip these over, some or all these are going to fall out. So not a big deal. We'll just put them back. We'll just do them a few at a time. But this is again where, as I mentioned, kinked pin headers can be useful. Another thing you can do is if you have a solid surface handy, like a block of wood or something like that, I could take these and actually maybe I use the sponge isn't really big enough, but just take something that's solid like this, and I can put them on that surface, and then I can flip them over like that. Then you'll see me slide them in from the side. We'll see if this works. You can then hold your headers in so they don't fall out, and some of them fell out anyway. Well, it was worth a shot. So I got some of them. So that is okay. Again, there are neater ways to do this. This just fits with what I have on hand, and I didn't have anything handy to flip it over. And again, I've got a big blob of solder on here, so I'm going to clean my tip real quick before I go back. Again, for this, as I mentioned before, I'm going to just do 1 pin in a corner to make sure I get these straight, because you can see this is wobbling around quite a bit. So that header is now attached. I'll make sure it's flush. So that one's attached as well. That dirty bastard was trying to steal my solder. Okay, so there we go. So all those guys are in. So Now you turn it over and you make sure everything is flush, which in this case I think it actually is. Just to make sure though, I'm going to turn it over and put some pressure on this. There, and hold that a little bit. Yep, it's flush. Okay. This guy, as you may be able to see, is not. That guy right there where my finger is, it's at an angle. So what I'll do is I'll put my finger on the board, again using my fingernail so I don't burn myself, and then I will just put the soldering iron here, touch it to melt, and press down, and presto, now it's vertical. Hopefully you can see that. So there we go. Now we'll put the headers in that fell out of the board. So this jumper block right there is one of them. So what I'm going to do because of that is I'll just take it and hold it one by one, flip the board over and put it down. So now that it's trapped, again the board wants to pop up. So I'll just do one pin. Hopefully you can see what I'm doing. We got one pin. See if that's flush. And yes it is. And then my other header that fell out is this one right there. This 3-pin header. So I'll flip it over and do a pin. Now, and once I get all these pins in, then I can come back and solder the remaining pins. Once I know my headers are straight up and down. And that one I got straight. So now I can come back and solder the rest of the pins in the headers. With these headers, they are just little bits of tin-coated tin or whatever, or coated metal there in some plastic. And the plastic's a little bit heat resistant. I forget exactly what type of plastic they use on the headers themselves. Plastic is slightly heat resistant, but even so, it's a good idea not to hold heat on them too terribly long, because you can definitely melt the support material that the headers are in. Again, not the end of the world. You can always replace the headers or whatever, but still, it's good to just move along and move at a reasonable pace. That's one of the reasons I mentioned earlier that I don't set my iron at a ridiculously high temperature. Some people do like to do that, but if you do that, you got to work fast. And I like to be more deliberate. You'll notice I keep spinning the board around. And it's because for various joints it is more convenient, 'cause I'm right-handed, to spin the board a certain direction to be able to get the iron in there. Okay, let's see what else I missed. I didn't see anything there that I missed with these. I think I've got them all. Yep, looks pretty good. I did actually fill in a via with some solder over here. I did it right there, but I don't think it makes any difference. But just to give it another little demonstration of the desoldering gun, I will pull it out and clear that via. So I have to wait for this gun to warm up a little bit before using it. It doesn't take very long. The gun is impatient. There we go. It looks like it's good. Yep, and it's melting solder properly. Just place it on the hole. Looks good. Just trying to get a little bit extra solder from this lead right here. There we go. I think I quite cleared the hole. Mind as I'm moving myself as I'm doing this. Nope, it's still not completely cleared. There we go, hole clear. Again, definitely not necessary. It would have been fine even if I left the solder in the hole, but gave me another opportunity to demonstrate using the desoldering gun, and it's definitely one of my favorite tools. It's made my life so much easier since I started doing that. So if you have a chance, it's awfully nice to have one. Okay, so all those are in. We're getting close to being done. Next thing we're going to do is we're going to put this DE9 connector in. Assuming I can find it in my box. Here we go, I have a pair of DE9s. Oh, I'm sorry, these are DE15s. They are not DE9s. Actually, and DE is not correct. It is another, I forget what the 15 pins are. I had completely forgotten that the 5200 actually used that many pins, but it makes sense because unless you're going to have some kind of a serial protocol and some decoding logic to decode the buttons, you need a fair number of wires to map to all those connections. So there isn't that on this board. So for this, we just push it in. And I'll show you something a little bit different on this connector. And it snaps in nicely. So here, these lugs here, they're grounds. They're attached to the ground plane of the board, but they're really more there for physical attachment. So they really just, they make sure this is strong because this cable is going to get connected and disconnected repeatedly. Let's go ahead and solder those guys in. Clean my tip again. So this one we don't have to worry about being straight up and down because again the physical connection between those retaining lugs there will keep it in place. So I can just go through and just start soldering pins. There we go, that's one row done. So I'll flip it around and do the other row. One thing you can also do, depending on how sensitive the components you are soldering are, you can choose to do a set of pins and then move on and do something else on the board somewhere else and let the affected area have time to cool off if you're worried about damaging something. In this case, there's nothing particularly sensitive here, so I'm not too worried about it. So I'll just go through and do these in order. But again, if this was a very heat sensitive component, which some ICs are, and all ICs are somewhat heat sensitive, I would go and move on somewhere else. See, all those are nicely in. They're nice and they're definitely nothing shorted and nicely soldered, nice and shiny. So now we're going to solder in the lugs. This is probably not strictly necessary. They probably have a good enough mechanical connection, but I like to do it. One, I can't tell you why, but I find it fun to fill in large holes with solder. I really don't know why I do, but I do. It also makes sure that we have a really good connection to the ground plane. You can see we have a nice, shiny, big solder joint there. This is where a joint like this, which is attached to the ground plane will suck a lot of heat out of your soldering iron because it is a lot of the board. This is where having a good and powerful soldering iron or tool works well. It's where a cheap, just a pencil iron, it's not a soldering station, can let you down. It can be more difficult to solder on heat sinks and things like this and things touching a big amount of ground plane. So there we go. So almost done. And I can have fun and press some buttons. Yee! Boo, 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 pew, 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 pew. I must be getting giddy. It is getting late. Okay, now, did I pull out thumbsticks? I did. I did. So we'll put this back in the box. I had originally thought maybe I was going to solder both of these controllers tonight. I think I won't. So I am getting tired. I have visions of putting my head on my pillow. Joining my lovely wife in the bedroom. Nothing naughty meant, of course. I just enjoy her company. So, let's pull out these joysticks. they have a bunch of pins. Interesting. That would probably explain why there are so many holes, so many vias drilled in this board. So let's look at how these are in. So I can see, looking at my picture, that the white connections go up. Ah, that explains why there are so many of these. So a couple of these pins are a little bent. Let's straighten them. And with these thin pins, it sometimes takes a little bit of fiddling to get them to go in. Definitely take the time to do that. It can be a pain in the butt to straighten legs once you've bent them over, so it definitely makes more sense to do it from the start. So you can look at what you're doing and see what pin is giving you trouble. In my case, it's these white pins on the top. Let's see if that one's a little bit bent. To admit, I'm slightly shocked that I do not have any feline assistance this evening. Aha, it went in. There we go. So now we're just going to get these side pins in. There we go. Let's see if they're all in. Oh, interesting. This joystick has a push down button as well. That's why it has so many pins, because it has a lot of possibilities here. So these things are really cool. I think this is, I'm trying to remember if this is a Seed Studio part or an Adafruit part, or I'll look at my list and look it up and see where these joysticks came from. SparkFun. So that's who made these. They're pretty nice, actually. Yeah, it definitely feels pretty darn good. I believe that also the caps will come off of these. Yes, they will. So this will allow you to see a little better how this inserts into the board. So you can see it there. Again, this cap just slides right back on. It's a D-shaped cutout in the back. That'll make it so if I make a 3D printed case for this guy, that we'll be able to easily attach the case. Okay, so we will solder that guy on. Again, clean my iron, as you've heard me say a bunch of times. I'll do a couple big pins first. Get this retained. There we go. Okay, make sure we are flat on the board. Yes, we are. So for any of you all who are new to soldering, I will, in the description of this video, I will post a list of tools that I have shown here, and some basic getting started with soldering tools, if that's something you're interested in. A board like this is not terribly difficult. The soldering itself is actually very easy. The thing that's more of a challenge is the fact that the markings in this board are not completely clear, so you have to have a little bit of knowledge about how things work. It's not huge, it's not hugely complex, so you probably could figure it out just getting started, but it's good to pick a simple project like a little clock or a timer or something like that as your first soldering project. This component right here, this thumbstick, is somewhat heat sensitive. So this is one of those components where you don't want to spend too long because, again, there's a lot of little plastic pieces in here. So it would be very easy to apply too much heat and to melt something. Looks pretty good to me though. So there we go. So it is complete now except for one tactile button, which I didn't put on because I wasn't sure of it. You also notice that I did not insert any of the ICs. I will be able to, I can definitely insert the IC for the digital potentiometer, because that does not need to be programmed. However, the IC for the microcontroller does. So I will need to program that first. So I will use my EEPROM programmer to do that. So now I'm looking to see where I put the other tactile switch when I threw it back in the box. I might actually just go ahead and stick it on the board and just deal with fixing it later if it's an issue. Because I really like finishing things. It really makes me feel good to finish a project and get it all put together. I'm sure I put it in here somewhere. Nope, those aren't it. Where did I put it? There they are. They're the ones I'm looking for. Again, these are SW404ND. I'm almost 100% sure that is what was specified. SW405ND. I wonder if that's what it is. Yeah, SW405ND. I think I ordered the wrong part. So let's take a look on the DigiKey page. I'll actually try and show you on my iPad here. We'll see if that works. Oh, I see. The only difference between the 404 and 405 is color. Doesn't make any difference. So I ordered the right part. The ones that were specified were yellow, but I think DigiKey was out of stock when I made the order. They're back in stock now, but yeah, not a big deal. So I did order the right stuff. So that means that here's the picture. Again, I'm showing you an iPad secondhand, but these are the switches that I am talking about right here. This blue one and that orange one right over there, these two. And as you can see, those are much bigger, and they're round and not square as the BOM lists. So it just means it's a slightly different switch. It's not a big deal. So excuse the slight change of angle. I had to plug the camera in. Hopefully it won't shut down now. Hopefully we'll get through this. I'm not sure if my charger, it's like I'm putting out 5.06 volt, 0.6 amp, so hopefully that is enough to keep the camera recording. We're almost done here, so not a big deal. You didn't really miss too much. I was just commenting on the fact that I've loaded up my tip here of my iron, and the reason I've done that is because these legs are not all the way through the board. I have to sort of hold the switch in place and then sort of do this. I don't have enough hands for that. I could pull out my helping hands, but this is another technique. And what I'm going to do is just dab some solder on the board. This doesn't have to be necessarily a particularly good joint, just enough to hold it on there. So now I can go along and do a proper joint on the others. Let me clean my tip first. This, I mentioned before why you want to do things in order. This is why. You can see my board is somewhat tilted because it's sitting on the joystick. So there we go. Nice signage joint. And you'll see the difference there. So hopefully you can see here, this joint right here I'm putting it with the iron is a little bit gray and not very shiny, whereas this one's nice and shiny. That is a cold solder joint. So all I have to do to fix that is move the iron back over and reflow it. There we go. And if we look at the other side, you can see that it picked up and flowed through for those legs. The top joint did not flow through fantastically, so that gives us another excuse to pull out the braid and clean it up. Again, what I'll do is I'll just plop it down, suck some solder out of there. There we go. And there we go. Now it has flowed nicely. So you can probably see that that hole is filled on the top. If it's a problem, I can always go back and put some solder on the top of the board as well, but this is fine. Now my other two pins are that one and that one. So we'll go through and press down the board a little bit. Put some solder back on my tip, because again the braid took all the solder off my iron. Press down there and put some solder on down and hold it for a second and give it a chance to flow. Okay, and same thing for our last connection. Okay, we look to the other side and these look like they flowed through nicely. So there's our switch mounted on the board, and it is in the position I want it to be in. So now if you're playing, like a lot of controller boards, you have a slightly offset fire button in the place where it's supposed to be. There probably were other holes here I could have used with these, because again, these were the specified switches, but this should do. Okay, so now we're done. So the next thing we do is we go and we clean the board. So to do that, I need a couple things. So I'm going to use this. This is MG Chemical Superwash Electronics Cleaner. I'm going to get out a sacrificial microfiber cloth and my anti-static brush. This is something you definitely do need when you're getting started soldering. What I'm going to do is I'm going to take this wash, take the cap off, and spray the board down with it. And then what I'm going to do is I'm going to put the cloth on top and then scrub the board. You can see there's a ton of that. So now I'll put this cloth on and go at it. So what I'm doing here is I'm picking up flux. You can see I'm crumpling up my cloth, and again, if I cared about this microfiber cloth, of course I'm wrecking it. But what I really want here is something that's lint free. If I did this with a paper towel, I would have paper towel pieces everywhere. So what I'm just trying to do is I'm trying to use the microfiber cloth to suck up the flux the flux residue once I break it loose with the brush. And this did okay. It's not great, but I'll probably have to do this some more. Definitely you can hit it more than one time, and you can also go at it directly with the brush to loosen the flux if it's not coming up. And again, you can see the flux on the board. It's sticky and it looks like not shiny. So then I can go and take this and sort of press it down and pick up the loosened flux and take it away. Because what I want is a nice shiny board when I'm done. And this board is certainly still not that. This stuff is not stuff that you want to get all over your hands all the time. You can see that hands are changing color. It is not terrible for you, but it is methyl 2-pentane, methyl 3-pentane, dimethyl 2,3-butane, dimethyl 2,2-butane, pentane, and N-hexane, which means it is seriously flammable, and it is not stuff that you probably want to have on your skin forever. So I will be washing my hands as soon as I'm done here. I'm sure someone in the comments will give a better recipe for easier cleaning of boards. If anyone watching here is doing this. You can also take isopropyl alcohol depending on what exactly flux you're using, and you can read in your flux what is the method for cleaning it. The flux I'm using is quote-unquote no clean flux. It means you don't theoretically have to clean it off the board at all. It means that it is not corrosive and will not eat your board. I still do attempt to clean my flux up somewhat. It's just good practice. And I now have it on top of the board too. I have some of this cleaner, but it looks okay. It's not perfect, but it looks okay. So there we go. there is a completed Atari 5200 controller. Now I just need to program my IC. Actually, I will show you that. I will. That's one more thing we can do before we finish up this video for tonight. And it's probably been rambling on. I'll probably do some trimming so you don't have to watch hours and hours and hours of this. But what I can do is I'll show you how to insert an IC. Again, I see some electronic cleaner under there. Okay. So let me get my digital potentiometer out. So I do not need to program that. There's my microcontroller. Where is my digital potentiometer? It is in the other foil package. So you'll notice these packages are a little different, and the reason that is these are anti-static. Hence the label I just tore. It says caution electrostatic sensitive devices. What you can do is, I have a power strip over here, it's metal, so I'm reaching over and touching it to make sure that I am not going to shock the IC when I touch it. You can also wear a wrist strap. I'm not the biggest fan of wrist straps. So here is our digital potentiometer, and you'll notice that the legs are a little bit splayed out. That's because this is a brand new chip. It is not reclaimed, as plenty of the chips that I use are, because I work on a lot of vintage stuff. What that means is that we have to form the legs. Because if you look at the board, this is the socket it's going to go into right here. The legs don't completely line up. So I mentioned, I'll show you different ways of seeing pin 1. In this case, on this IC, it's that little circle right there. Hopefully you're getting a view in that. So I can't really tell on the camera, but it's a little circle right there, it's pin 1. So that goes up to the top of the board, but these don't line up. These legs will, if I put them in here, the other legs would miss. So to fix that, what we do is you can do a couple things. One, there's a thing is a IC forming tool that you can get. But you can also do is just take your IC, place it flat on the table, rotate it up a little bit, and just make your legs straight by pressing down. And there we go. We've formed our legs to more or less straight up and down. Hopefully you can see that there. Now we can take it and insert it in the board, and it should line up. And it does. So again, we don't want to bend legs on ICs. Again, you can fix it for sure, but it's best to form the legs first. There we go. IC inserted in board. And because these machine pin sockets are circular and the IC legs are sort of flat, it actually grips them very nicely because you have the flat edge of the leg on the IC sort of scrapes against and has more contact to the circular connector, so it works nicely. So there we go. The only other thing we need to do is put our jumper shunts on, so I guess I'll go ahead and do that. Again, it's not going to do anything yet because I don't have a 5200 here. Now it's actually one of the more interesting things. I don't actually own a 5200, so I cannot actually test these to make sure they work, so we're just going to have to hope they do. Probably a good chance it's not a complicated circuit, but I'll give them to my friend and he will tell me whether they work. Okay. So let's look at where our jumper should go. Again, I'm just looking at the picture here. I'm not doing anything too serious here. I'll check my jumper positions. I'll go ahead and insert them on the headers. So there's one there, one there. So there's supposed to be by default a jumper here. And I'll check and make sure what all these jumpers actually are. Appears to be one here. And that's it. This block does not have anything in it, nor does this one. So this might well be a programming header. Yeah, in fact, I think that's what these are. I think these are programming headers, and that's why they're not jumpered. So these are jumper settings. So this is a header of 2, and these are two 2-pin headers, and that's a header of 3. So there we go. We are done. So thanks for your time. I hope this was interesting. I hope it showed you it's not challenging to build something up like this and can be quite fun. I very much enjoy this process. I love building things. So I absolutely adore this sort of work. I love the smell of melting flux and solder and all that. And I just love putting things together. So that goes into electronics. And ooh, I just noticed something while I'm jabbering on here. I missed right there. If you see next to, I don't know if you can see next to my thumb, but I missed 3 solder joints, which is why you check your work when you're done. So I'm going to go back and do them. 1, 2, 3. Now we are done. There we go. I also noticed something else I missed. There is another button right there that I did not put on the board. Boy, I'm getting ahead of myself. Saying I'm done, and I'm really not. What button is that one? It's a button there's only one of. So I only have one spare switch, so again I do not have enough parts to do the other controller. It's interesting that the BOM omits listing this part. We'll drop Dr. Baker a note and let him know the BOM needs a little updating. So that goes right in here. I'm just going to use another of these white switches. Again, I bought 25 because it was cheaper. So it's a good thing I did. I actually could have used 26, but I'll put that in there. In the picture, it's actually shown as white. I'm sorry, as black tactile switch. But again, I didn't buy any of those because it wasn't in the BOM. Interesting. The other thing I didn't buy is a 15-pin cable. Which I could have done. That was in the BOM. Just looking to see if I missed. No, it's just that particular tactile switch is just not present. Well, that's the way it goes. Anyway, so I'll just take and I'll solder this guy in, and then I will finish this video up. And again, as I mentioned, this is why you solder things in size order. It is more challenging now to do this. And also, I will have to go back and re-clean my flux, because I will be depositing some new flux on the board by doing this solder work. There we go. It is done. So that is in. The only thing it's missing, again, is our microcontroller, or AT-Tiny85, which goes in this little 8-pin header there, but there's no point in putting that in because I haven't programmed it. So I will have to do that. And then just to show you what this thing's going to look like, I will grab my caps for my buttons and stick them on. Again, I should have some bigger caps, it looks like. It looks like the design for that has changed too, but I'll stick on the ones I have. So you can see what it's going to look like. There's one. And there's two. So these guys just stick on the top of these buttons, just like this, and just press on. So there we go. And here. There we go. There's our controller. So again, now we are done. So I will program the microcontroller, and then this guy should work. Woohoo! Boo boo boo! Pew 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 pew. Hope you enjoy my sound effects. So anyway, thanks for watching. I hope this was useful to you, as I said before, and I hope you enjoyed. Please consider liking, and if you like what you saw here, please consider subscribing to my channel, and I hope to see you again soon. Thanks. Bye-bye.
Thanks for sticking with me this long. If you're interested and you'd like to join me for the next part, we'll be continuing with the build of the 3D printed case for this controller, and I'll show a little bit about how to program the microcontroller we use here. So thanks again, and have a good evening.